If you could offer a truly unique and well-proven system designed to provide a superior heating and cooling solution to your clients at a fraction of the normal installation and operational costs, would you be interested? What if the concept not only offered reduced capital cost and impressive energy efficiency, but came with a 10-year track record of success? It sounds like the perfect system, right? Well, it is. Introducing IPS, the Integrated Piping System. Integrated Piping System is not just the industry's best-kept secret. It's a proven system that comes with a track record of successful projects ranging from 4-unit condominiums to 40-story high-rises. IPS is an affordable green solution. That's right. Typically, affordable and green aren't mentioned in the same sentence, as green systems are usually costly, often cost-prohibitive. Engineers are asked to design green systems, and then when it goes to bid, developers and mechanical contractors and wholesalers chop, chop, chop until there's no green left. With the integrated piping system, you get the best of both: the efficiency and energy savings of green and the affordability of a low-tech solution. IPS is suited for hotels, motels, condos, senior housing, dormitories, and apartment buildings. These types of buildings have a common thread. They all have central circulating domestic water because they house people and have a domestic hot and cold water requirement 24/7, 365 days per year. This means they have to have domestic hot and cold water piping in the buildings running to each occupied tenant space. What if we could take advantage of that existing piping infrastructure and the domestic hot and cold water already in the building to satisfy the heating and cooling requirements using the very same pipes? Well, not only can we do that, but we've already been doing this safely and effectively over the past 12 years. In order to understand the impact that IPS makes, we need to explore the advantages and disadvantages of the systems being used in the industry now. This schematic shows a 4-pipe fan coil system, probably the most sought-after system today if the budget will allow. The advantages of a 4-pipe fan coil system are: number 1, superior comfort, because the tenant can have either heating or cooling 365 days a year, selectable from the thermostat in the space. Number 2, superior efficiency, because it has a central boiler and chiller that can be selected to be as efficient as the budget will allow. The main disadvantage of a 4-pipe fan coil system is high cost of installation. This system requires 7 pipes in the building, not counting sanitary drains, 4 for the heating and cooling, and 3 for the domestic water system. The pipe, equipment, and additional labor costs while delivering a comfortable, efficient system is cost prohibitive to many projects. The next system of choice, typically, is the 2-pipe fan coil system. The advantage here versus the 4-pipe hydronic system is that with reduced piping, the building will now have 5 pipes in the building, not including sanitary, instead of 7, which translates to reduced installation cost. The building also still has good efficiency since the 2-pipe hydronic system still has a central boiler and chiller. The main disadvantage with the 2-pipe system is that it is an either-or system, which means all occupants in the building have to have either heating or cooling. So if the southern exposure of the building in September requires cooling, but the northern exposure still requires heating, there's a loss of comfort. Guests or tenants now have a very limited control over their comfort. You can't make everyone happy with a 2-pipe system. Another system choice available is the water source heat pump. The advantage here? A water source heat pump allows the tenant to have heating and cooling with the same 5 pipes as a 2-pipe fan coil system, because the heat pump can provide cold water for cooling, and if someone needs heat, they can have heat off of the hot water rejected from the compressor heat. Using 5 pipes keeps the piping and installation costs at the same level as a 2-pipe fan coil system. But because different spaces can call for both heating and cooling simultaneously, it offers superior comfort over the 2-pipe. No chiller is required now because the heat pump can create cooling and utilize the compressor reject heat for heating. The disadvantage to using a water source heat pump system? The compressor or heat pump, which would be required in every space, is noisy. It's like having a mechanical room in the space itself. In addition to the noise factor, the tenant or guest has to be disturbed in order to service the equipment. The compressor heating is electric heat, so the building transformer itself has to be increased, and 220-volt wire has to be run around the building to each heat pump to drive the compressors, increasing electrical installation costs on the project. Another major concern is there's potentially not enough heat created by the heat pump, so a secondary heating boiler is added to do what the heat pump can't do, adding additional cost and equipment. The last system of choice is the infamous PTAC, a packaged terminal air conditioner, also known as the window shaker. The advantage of this rudimentary system is that these PTACs will provide heating or cooling 24/7 to the tenant, and it has some of the lowest installation costs of any system on the market. But the disadvantages of this system far outweigh any advantages it may claim. PTACs are not only the noisiest systems, but have the highest day-to-day costs to operate, creating significant issues in situations like hospitals and hotels where the operating is footing the electricity bill. PTACs are also the least comfortable of any heating and cooling system and one of the most invasive, as they require a 16 by 42 hole in every room to the exterior of the building. All of these systems have some benefits, but for each of them, the disadvantages far outweigh them, especially compared to IPS. So, finally, what makes the integrated piping system so unique? IPS is a remarkable system that features the combined advantages of all the other systems, and more. 1. It offers comfortable heating and cooling as selected by the tenant or guest in the space itself from the thermostat. 2. It offers significantly reduced installation costs, as it doesn't require 7 pipes like the 4-pipe fan coil or 5 pipes like the 2-pipe fan coil and water source heat pump system. IPS instead used 4 pipes, 3 of which are domestic and already required in our target buildings: hotels, motels, condo, senior housing, dorm, and army barracks. Less piping means lower installation costs. And 3, unlike the water source heat pump or PTAC systems, there is very little noise without the mechanical room in the space. The only disadvantage? It requires domestic water piping throughout the building, so an office tower or other similar building not having 24/7 occupancy may not be an ideal fit. But for any occupied buildings, IPS is ideal in any area on any project. If we were to chart all the systems we've discussed, putting them on a graph where the x-axis represents installation costs and the y-axis represents user comfort, IPS would land right in the sweet spot. Changing the graph now to reflect operational rather than installation costs, IPS wins again. For building operators and owners, IPS offers huge operational savings while still delivering a high degree of comfort. And finally, when changing the graph to plot system efficiency along with comfort, IPS once again outperforms traditional systems. It delivers high efficiency and high comfort, the same as a 4-pipe fan coil, only in a much more economical way. As you can see, IPS is the only system that provides low installation and operational costs with a high degree of choice and comfort to the tenant or guest. To date, we have over 170 major projects installed in the U.S. and Canada, all using IPS to save the owner-operators money and provide quiet, on-demand comfort. IPS isn't a customer configuration or one-off design. It is a tried and true system and proven over time. So, now you know why IPS is better than the other system options, but how does it actually work? With IPS, the domestic water piping is used to provide not only the domestic water, but also for heating and cooling the space as needed. The same pipe that feeds the shower and sink also feeds a terminal unit which is placed in each space that requires heating and cooling. A terminal unit is not just a normal fan coil, it's actually a coil built out of NSF 61 certified copper, rated for potable water use. Utilizing a 6-row coil option with circuiting allows us to use cooler heating water temps and warmer chilled water temps. We factory mount 2-way valves, which are IAPMO rated for less than 0.025% wetted lead content for portability, and each terminal unit has a control board that opens the heating and cooling valve once a day for up to 5 minutes to eliminate any stagnation in the system, ensuring the water stays fresh and the valves are properly exercised. When the space-mounted thermostat calls for heat, a 2-way valve opens and 140-degree domestic water flows through the coil and provides heating for the space. 140 is code mandated for storing domestic water to eliminate Legionella, so this temp is used as a design suggestion. However, if the max distributed water temp allowable in a building is 120, we would simply size the terminal unit to accommodate this lower water temperature. Once the water passes through the coil and heats the space, it is returned back into the return pipe at a 20-degree delta T or greater to be reheated. To provide the cooling, we slightly modify the domestic cold water piping in the building so it can be used for both domestic and cooling in the building. A return pipe is added to the domestic cold water to make it a continuous circulating system, just like the hot water. We then add a chiller to the loop and isolate it by a double-wall stainless steel heat exchanger so it can be used to maintain our domestic loop at design temperature. Since a chiller is not potable water rated, using a plate exchanger is used to isolate it from the water itself. When the thermostat calls for cooling, a two-way valve opens on our designated cooling coil and mechanically chilled 50-degree domestic cold water runs through the coil to provide cooling for the space. Once the water has passed through the coil and cooled the space, it is returned into the return pipe we added to the cold water piping system, and it is sent back past the chiller to be recooled if required. In areas where water from the local municipality coming into the building is colder than 60 to 62 degrees, then the chiller isn't required to work as hard and economizer cooling is achieved. Economizer cooling is simply the use of water temperature supplied to the loop from the city supply that reduces the need for mechanical cooling. For every degree that the city water is cooler than 62 degrees, more energy savings is achieved. In fact, with lower city water temps, every gallon of water introduced into the building to be used for daily domestic use offers free cooling to the space. The integrated piping system uses the same 3 domestic water pipes every building is required to have, and simply adds one, the domestic cold water return, to give the clients a true 4-pipe heating and cooling solution. And we do it at a fraction of the installation and operational costs of traditional hydronic systems. For more information on how IPS can help satisfy your heating and cooling system demands and save upfront and long-term money in the process, contact Williams Comfort Products today.